Okay, this is F.IF.6. This is Interpreting Functions, Standard 6, Video 2. We're going to be talking about direct variation today. Please copy down these terms in your journal and define them. All right, this is a very wordy looking slide for you. It talks about all the relationships in the category called direct variation. In the purple, you're going to see important wording such as y varies directly as x, or another way to say that is y is directly proportional to x. It has the same proportion, and y is equal to ax for some constant a. And a, if you look at it, a could be also known as your m or your slope. It's your constant rate of change. You know, I've seen elsewhere that they, instead of using a, you might see something like y is equal to kx, where k is the constant of proportionality. And then, you know, we're going to be looking at graphs. We're going to be looking at you know, some different examples that have this idea of constant of proportionality. The first one says y is equal to ax, and given that y varies directly with x, that is very important wording right there. So you see that it says y varies directly with x, and that means that y is going to be your quantity of interest. In other words, it's your variable that has been set aside or solved for, and everything else is on the other side. So given that y varies directly with x, I want you to use the given values to write a direct variation equation that relates x and y together. All right, so simply put, you're given a y value. So y is equal to -5, and that is going to be equal to your a multiplied by your given x value, which is 15. Now, if you were to figure out what your constant of variation is, that would be your a term. You would do what? What would you do to both sides to figure out what a is? Okay, you do your inverse operations. So if 15 is touching a, that means multiply. We're going to do the opposite and divide both sides by 15. So if we simplify that, your constant of proportionality a would be reduced to -1/3, and that's really your slope. I mean, if you think about it, if we put it into y is equal to mx, your slope is going to be your rate of change, which is -1/3. Okay, and when we're dealing with ideas of direct variation, there's going to be no b. We're not going to have any y-intercept when you're talking about direct variation, because we want this graph of the line to go through the origin, and the origin would be +0. So if there's any number integer here in this b category, you are not going to have what we call direct variation. It is not going to be proportional. All right, so I set up a little example here. Now, I didn't fill anything in. I thought maybe I would plot some points and give you a scenario that this graph might be showing. So I have on my x-axis time in hours, and it is being compared to a distance in miles. So, you know, to grandmother's house we go. Maybe grandma's house is 180 miles away from where I live. And I am going to pick an average rate of speed. And if you're thinking about tollways or expressways, you know, maybe taking the side roads there, I would like to average 60 miles per hour. So if I graph 60 miles per hour, starting at the origin, for every 1 hour, I'm going to travel 60 miles. So after hour 2, if I go another 60 miles, I'm going to be at 120. After 3 hours of travel, I should be all the way up at 180. And what we have here is we have this thing called a constant rate of change. So if I were to put it into y equals mx form, knowing now that we are changing the m with this thing called a, your constant of proportionality, it's just saying, what is your constant rate of change? Well, if I put it as a unit rate, for every 60 miles traveled, it's going to take me 1 hour. All right, and I can think of many scenarios. Where am I going to be after, let's say, 4 hours? You can make predictions based on your graph and your information of the constant of variation. You can make those predictions. So if I were to say, where am I going to be after 4 hours? Well, we have y equaling, what is your constant rate? 60 multiplied by, well, what is your x? Your x is your time. So we have 4 hours. So your y is going to be 60 times 4 is 240. So we have y being 240 miles away after 4 hours of travel. All right, the last example I have involves a fish tank. And wow, another long paragraph. So it says the number S of tablespoons of sea salt needed in a saltwater fish tank varies directly with the number W of gallons of water in the tank. So what are the important words that I see just in that first sentence? I see the S, which is the sea salt. So why don't I underline that in red? So S represents the sea salt in the tank, and it varies directly with the number W. Maybe I'll put that in purple. So W, which represents your water. All right, and then it tells you a little bit about a pet shop owner, and he has a recommendation of how many tablespoons of salt you should put in a $20 or a 20-gallon tank. All right, so let's write a direct variation equation that relates W and S. Okay, so what do I have first? S is equal to your constant rate of change, which I don't know yet, multiplied by the W water. Okay, and it says that right up here. S varies directly with W, and S is the sea salt and W is the water. So if I want to find out this rate of change with what the recommendation of the pet shop owner is, I'll plug in my given information into my direct variation equation. So what is S? S represents the sea salt. So he recommends adding 100 tablespoons of sea salt. So 100 is equal to AW. Well, what is the W here? The W is the water. So this is a 20-gallon tank. So A times 20. And now I need to figure out, what is my rate of change? What is my constant of proportionality? So let's divide both sides by 20. And I know that my constant is going to be 5. Okay. So if I were to rewrite that into my, I guess you could call it slope-intercept form or constant proportionality form, I would have what? So S is equal to 5W. All right, now looking at the second question, it says, all right, maybe I don't have a 20-gallon tank, maybe I have a 30-gallon tank. So if I use his proportional reasoning, what would I say about this 30-gallon saltwater fish tank? Okay, so S is the salt water. I have 30 gallons of water, so S is going to be equal to 5 times the 30 gallons of water, right? W represents the gallons of water. So the amount of sea salt needed would be 150 tablespoons of sea salt. So if you want to write that out in a sentence, reword the question. I would need 150 tablespoons of sea salt added to a 30-gallon saltwater fish tank. So 150 tablespoons. It's good to put in your unit. Tablespoons of sea salt. Okay. In your journals, please define the given terms and write a few sentences on what you learned from the video. As always, write down the questions. Did you get lost? Was the wording very difficult here? Did you see the relationship between the A in the y equals ax and the possibility of relating to m when we were graphing these linear equations? All right, I'll see you in class.